Good day everyone. So today we're going to discuss about naming ionic compounds. Alright, but let us first discuss the big picture. Okay, so compounds can be classified as inorganic or organic. And inorganic compounds can be further subdivided into ionic and covalent or molecular compounds. Okay, let me adjust the frame. And we can further divide ionic compounds into ionic compounds with cation that has only one possible charge, and also ionic compounds with cation that has more than one possible charge. There you go. Alright, so for today we're going to focus on naming ionic compounds. Alright, so we will discuss how to name the ionic compounds with cation that has only one possible charge, and ionic compounds with cation that has more than one possible charge. Alright, so let us proceed with the first one. Ionic compound with a cation that has only one charge or one possible charge. Alright, so these metals can be found in group 1A or the alkali metal cations, and group 2A alkaline earth metal cations, and the following: silver, aluminum, cadmium, and zinc. Alright, so therefore, if the metal is found in group 1A, the possible charge is only one positive. If the metal is found in group 2A, the possible charge is only two positive. Alright, and we have additional 4 metals that has only one possible charge, and they are silver, aluminum, cadmium, and zinc. Alright, so let us recall the representative elements. Let me just add this. So for group 3A, the possible charge, net charge, when the metal formed the ion is 3 positive. For group 4A, we have 4 positive and negative. For group 5A, the tendency is to form anions. So the possible net charge is 3 negative. For 6A, that is 2 negative. For 7A, that is 1 negative. And for 8A, 0. Alright. Now, again, remember. Okay, let me just emphasize this one. If the metal can be found in group 1A, the possible charge is only 1 positive. And if the metal can be found in group 2A, the possible charge is only 2 positive. Alright? And we have this additional 4 cations that has only one possible charge. Alright. Now, let me give you some examples. Alright. But before I give you some examples, let us first read the rules. So, the first rule in naming ionic compounds, where the cation has only one possible charge, is name the metal first. That's the first rule. Then second one, if monoatomic anion, add IDE to the root term of the element name. And number 3, if polyatomic anion, use the name of an ion. Alright. So for you to understand these rules, let me give you some example. Okay. So let's say we have the following ions. We have Na positive and we have O2 negative. Okay. Let us derive the chemical formula that we can have from these ions. So what we will do is what we call crisscross. Okay. You have to draw a cross between the ions, and then that means that you're going to bring down the numerical value in the charge. So that will give us Na. We will bring down this numerical value, Na2, and this one has 1, right? Bring it down, so Na2O1, but we don't need to write 1. Okay, so this is the chemical formula that we derive from these ions. Now, let us name this compound following these rules. So, name the metal first. So, the name of the metal is sodium. And then, if monoatomic anion, we have a monoatomic anion here. So, add IDE to the root term of the element. So, the root term of the element is this, and then let's add IDE. So, the name for this compound is sodium oxide. There you go. Alright, let me give you another example. So, let's say we have Ca2 plus and we have N3 negative. Okay, if you're going to ask where did you get the numerical values for the net charges, again, we go back to this one, right? Okay, since calcium can be found in group 2A, so therefore the possible charge of it is 2 positive. And for nitrogen atom, you can find this in group 5A, so therefore when it forms the ion, which is nitride ion, the possible net charge is 3 negative. Now, if you want, you can check out the videos in naming ions, monoatomic and polyatomic ions. Alright, now again, let's derive the chemical formula from these ions. So we will do the crisscross. Okay, bring down the numerical value. So Ca3, there you go. Then we will bring this down as well. So N2. Alright, so the chemical formula is Ca3N2. Now, let's name this compound. Let's name the metal first. That's the first rule. So the name for this is calcium. And then, if monoatomic anion, add IDE to the root term. So the root term is this, and then add IDE. So the name for this is calcium nitride. There you go. Alright. Now, let me give you an example where we have a polyatomic anion. Alright, let's have Li, which can be found in group 1A. So, the net charge is 1 positive. And let's have this polyatomic ion. There you go. So again, I recommend that you check out the videos in deriving polyatomic ions and naming ions so that you will not have difficulty in understanding this video. Alright, so let's derive the chemical formula by doing the crisscross method. So we will bring down the numerical values. So 3, Li3, then we have PO4. Because there is only one here, one positive, so no need to write 1. Okay, so the chemical formula is Li3PO4. Okay, now this time we will follow this rule. Name the metal first, and then if polyatomic anion, use the name of an ion. Alright, so let's name the metal first. We have lithium, and then if polyatomic anion, so this is a polyatomic anion, just use the name of the anion. And the name for this one is phosphate. So therefore, the name of this compound, Li3PO4, is lithium phosphate. There you go. Okay, let me give you another example. So, before that, let me just mention this. If you notice, the cations that I use, Na positive, which is sodium ion, belongs to group 1A. Calcium ion belongs to group 2A. And lithium ion belongs to group 1A. Why? Because these cations, I use these cations because they only have one possible charge. Okay, now let me use a transition metal that has one possible charge only. Let's use zinc. So zinc ion, Zn2 positive, and let's have another polyatomic anion, which is, let's say we have this one. Alright, SO3 2 negative. Let us derive first the chemical formula. Let's do the crisscross. So we will have Zn2, okay, 2. We bring down 2, and then SO3 2, right? If that is the case, we can actually express this to lowest term. So our final chemical formula is ZnSO3. Okay. Now, or if you want, just cancel this out. If you see 2 positive and 2 negative, then do not bring them down anymore. Just copy ZnSO3. So that is our final formula. Now, how are we going to name this one? Let's follow the rules. Name the metal first. So that is zinc. And then, so since this is a polyatomic ion, if polyatomic anion, use the name of the anion. So what is the name of the anion? That's correct. This is sulfide. So the name for this compound is zinc sulfide. Again, if you do not know yet how to name the polyatomic anion, I recommend that you check my video in naming and deriving polyatomic anions. Okay, there you go. So, that's it. For naming ionic compounds where the cation has only one possible charge. Again, these cations can be found in group 1A, 2A, and the following: silver, aluminum, cadmium, zinc ions. Alright. So therefore, for you not to be confused, what we mean by has only one possible charge, let me give you an example. For example, magnesium. Magnesium can be found in group 2A. So therefore, the possible net charge for magnesium when it forms its ion is only 2 positive. it will never be Mg4 positive, Mg5 positive. No. The only possible charge is 2 positive for magnesium because you can find it in group 2A. Okay? So again, the cations that has only one possible charge are those that can be found in group 1A and group 2A, plus these four transition metals: silver, aluminum, cadmium, and zinc. So let me just erase this one so you can see the possible charges of silver, aluminum, cadmium, and zinc. So for silver, the possible charge for silver is only 1 positive. For aluminum, that is only 3 positive. For cadmium, 2 positive. And for zinc, 2 positive. There you go. Alright? So I hope you understand this part. So we can proceed with the next one. Now this time, let's discuss naming ionic compounds where the cation has more than one possible charge. Let me erase this one. Okay. The cation has only one, the cation has more than one possible charge. And you can find these cations in the D block. And these are what we call the transition metals. So if the compound has the cation that has more than one possible charge, we will follow the following rules. Number 1, name the metal first. Number 2, specify the charge of the metal cation with Roman numeral in parentheses. And number 3, if monoatomic anion, add IDE to the root of the element name. And number 4, if polyatomic anion, use the name of the anion. Alright, let me give you some examples for you to understand this better. So let's say we have iron 2 ion and we have iron 3 ion. Alright, so for this one, let's have O2 negative and then O2 negative. Alright, so oxide ion. Okay, let's derive the formula from these ions. Okay, we have Fe, let's just bring down, so Fe2O2, and then let's express this to lowest term, which is FeO. So this is our final chemical formula. Then let's do the crisscross for this as well. Fe2 and then bring down the numerical value Fe2O3. There you go. So if you notice, iron can have 2 positive or 3 positive net charge. So therefore, if that is the case, that means the cation has more than one possible charge. So we will follow these rules in naming these compounds. So let's name the metal first for this compound, iron. Specify the charge of the metal cation. So the charge for this compound of the iron is 2 positive. So 2. Iron 2. And then if monoatomic, since our anion is monoatomic, add IDE to the root term of the element. So this is the root term. Let's add IDE. So the name for this compound is iron 2 oxide. Now let's name this other compound. So name the metal first, iron, and mention the charge or specify the charge, which is 3. And then add IDE to the root term. So iron 3 oxide. There you go. Alright. So let me just say that this system of naming where you use Roman numerals to specify the charge of the cation is what we call stock system. Alright. Okay. So let me give you another example for the stock system. Okay. Let me just okay. Let me give you another example. So let's say, let me annotate. So let's say we have cobalt. Okay. Cobalt 1 positive, and we have cobalt. Let me just check the possible charges for cobalt, and it's not included here. Let's have copper instead. Alright, let me erase this one. Okay, so let's have copper 1 positive and copper 2 positive. Alright, so copper 1 ion and copper 2 ion. Let me erase some of the things that I've written here. Okay, there you go. Alright, so for copper 1 and copper 2, let's have a polyatomic anion. Let's have SO4 2 negative. Let's see that one. Okay, so let's have, or let us derive the formula from these ions first. Let's do the crisscross. So Cu2SO4. Bring down 2 here, then 1 there. There you go. And for this one, you can just actually cancel this out. Alright, so CuSO4. There you go. Or if you want to, you bring them down and then you express it in lowest term. Okay, so for this compound Cu2SO4, name the metal first, which is copper, and then specify the charge of the metal using a Roman numeral inside the parenthesis. So copper, what is the charge? 1. And then, since we're not using a monoatomic anion anymore, but what we have here is a polyatomic anion, just use the name of the polyatomic anion. And the name for that polyatomic anion is sulfate. So again, you may watch the video that I uploaded for naming polyatomic anions. So the name for this compound is copper 1 sulfate. Okay, how about this one? Let us name this. Name the metal first, which is copper. Then mention the, or specify the charge. The charge that we used is 2 positive. So just the numerical value, so 2. And then name the polyatomic anion, sulfate. So the name for this compound is copper 2 sulfate. Again, if you're using Roman numerals inside the parentheses, that is what we call stock system. In naming ionic compounds where the cation has more than one possible charge. But before, actually, instead of stock system, they use the conventional way of naming using ik and us suffixes. Ik and us suffixes. This is for the traditional system. Okay, so today what we use is the stock system, but it is also good to know how the traditional system works. Okay, let us apply that using this same example. So we will just use the us suffix for the root term of the metal and the ik suffix for the root term of the metal as well. But us is for the lower charge and ik is for the higher charge. So in this example, okay, we know that copper 1 has a lower charge compared to copper 2 ion. So therefore, the name for this compound using the traditional system is cuprous sulfate. Okay, so no need to write the Roman numeral for the traditional system. Cuprous sulfate, and for this one, it's cupric sulfate. Why? Because again, we will use the suffix us for the root term of the metal with a lower charge, and the suffix ik for the root term of the metal that has a higher charge. Alright? So cuprous sulfate, because copper here has one positive charge, and cupric sulfate because copper here has the charge or net charge 2 positive. Okay, so let me give you another example for the traditional system. Let me just erase. Okay, so let's do the traditional first and then let's proceed with the stock again. Alright, so let's have chromium. Okay, let me just check the possible charges for chromium. Okay, 2 and 3. Okay, so for chromium, two and chromium 3 ions. Okay, so let's have a fluoride ion. There you go. Okay, let's derive first the formula from these ions. So let's do the crisscross. So the formula will be CrF2. Okay, and for this one, let's do the crisscross as well. CrF3. Okay, let's use first the traditional system in naming ionic compounds where the cation has more than one possible charge. If you notice, chromium here can have 2 positive or 3 positive. Okay, so and then we will proceed with the stock system, or using the Roman numeral to indicate the charge of the cation. So let's use the traditional system first. Name the metal, which is chromium. Okay, just the root term, and let's determine which one has a higher and lower charge. So Cr2 positive is chromium 2. So it has a lower charge, so we will add the us suffix. So chromus, and then let's add IDE to the root term of the nonmetal. So this is the root term, and then let's add IDE. So the name for this one is chromus fluoride. And for this one, since this has a higher charge, we will add the suffix "ic" to the metal, to the root term of the metal. So, chromic. And then add IDE to the root term of the nonmetal. So, the name for this one is chromic fluoride. Okay? Now, let's use the stock system. So, for the stock system, name the metal, which is chromium. Include in the parentheses the numerical value of the charge, which is 2, chromium 2, and then add IDE to the root term of the nonmetal, since the nonmetal that we use is monoatomic fluoride. Okay, and then for this one, CrF3, name the metal first, chromium. Indicate the charge in the parentheses, 3. Then add IDE to the root term of the nonmetal. There you go. Chromium 3 fluoride. Alright. So, let me give you another example using the same cations. Last example, let's say, again, we have Cr2 positive, Cr3 positive. But this time, let's have a polyatomic anion, which is nitrate. Okay, let's do again the traditional system in naming ionic compounds with more than one possible charge for the cation and the stock system. So again, you can only use the traditional or the stock system for ionic compounds where the cation has more than one possible charge. Like this one, chromium can have 2 positive net charge or 3 positive net charge. So let's derive first the chemical formula. So the formula would be CrNO3 2, and for this one, CrNO3 3. Okay, so for the traditional system, since this has a lower charge, which is 2, this will become chromous nitrate. So, we added the "us" to the root term of the metal and then just mention the name of the polyatomic anion. So, chromous nitrate. For this one, since chromium here has a higher charge, so this will become chromic nitrate. So we added the "ic" suffix to the root term of the metal and then just mention the name of the polyatomic anion. So chromic nitrate. Now let's use the stock system. So in using the stock system, name the metal first. For this compound, name the metal first, which is chromium, and then specify the charge, which is 2, and then name the polyatomic anion, which is nitrate. So for this one, name the metal first, which is chromium, specify the charge, which is 3, and then just mention the name of the polyatomic anion, which is nitrate. There you go. So that's it for this lesson. I hope you learned, and see you again. Bye-bye.